Ladies and gentlemen, a very, very big welcome to Lecture 3, Information Technology Project Management. For those of you coming on the first time, very big welcome. Please make sure you continue to come on a regular basis. Thank you very much for all your work. Now, I would like to go and say that we are going to be talking about very, very important chapters starting this week, and then we're going to start building every single week on various calculations you need to go and know. So what I'm going to be doing today is I'm going to start with this calculation today. I'm going to start explaining to you this important topic, and that's a basis. From that basis, we're going to start building and teaching you more calculations almost every single week. So it's very, very important. We are coming regularly to be able to go and really learn those calculations. I know for a fact, if you don't learn those calculations, we're going to have the midterm exam that is coming up in week 6. You won't be able to do well in that. Last semester, the average was around 11 over 20 on that midterm exam. Many did not actually get the calculations correctly, and they were not difficult calculations. So we need to go and try to rectify that out this semester. And it's also important for the quiz, which is you have a quiz next week. For those of you who don't know, there is a quiz next week, and that quiz will also potentially include calculations of what I'm basically explaining to you today. So where we are now, well, we are going to be talking about the estimation of the various tasks that needs to go and be done. So this is after you define the project, you define what needs to go and be done, you understand what needs to be done, you need to start creating all of these estimation about the time required to be able to go and get things done, you know, start time, end time, and so on. We'll start basically building here an estimate and the project network, which really goes and relate to each other. But let's start basically first with the high level estimate that we start with at the beginning. We're going to need to go and understand today the estimating project times and costs are the foundation for really controlling the actual project and for planning the project. We're going to describe the guidelines for estimating time, costs, and resources. We're going to describe the methods and uses of the top-down and bottom-up estimating approaches. We're going to distinguish different types of costs associated with a project. So estimation, what is estimation? Guys, we don't know what's going to happen in the future, but estimation is really about us trying to forecast what is going to be happening in the future. Let me go and actually estimate what time is it going to take for me to go and complete the project. Let me go and actually estimate how much is it going to actually cost me to go and complete that particular project. The reason why you need all of those estimations, because you need to give your stakeholders, you need to give management some expectations about what they should be expecting when we are going to be talking about delivering that particular project. So when I talk about estimation, I talk about different type of estimation. I talk about top-down estimate, and I talk about bottom-up estimate. Top-down estimate is like you have a high-level estimate, and based on that high-level estimate, you use it to be able to go and estimate the time and the cost within your particular project. Bottom-up is more about let me go and get to the details, so the task that needs to go and be done, and let me go and estimate based on understanding those details and try to basically go and create my estimation accordingly. Now, there are many, many estimates, many factors that actually impact on whether I am going to actually be creating and deriving good quality estimates. What are they? If I am going to be estimating something for the next 5 days, it will be much more easier for me to go and estimate that than estimating something for the next 2 years. So the planning horizon will affect my estimation. The people I'm using to go and create my estimate will also affect my estimation. What if I am using people who don't have the knowledge and skills that is actually required? The planning project duration, the longer it is, the harder for me to go and get in terms of accuracy. The project structure and the organization. If I'm talking about people who are dedicated project structures, it is going to be totally different than having what we call as, let's say, functional structure, where you don't have a project manager typically focusing on ensuring the job basically goes and gets done. But if we go and talk and continue further, a lot of time you go and tell someone to go and create an estimation And what would they do? They go and try to bad estimate. So instead, let's say something's going to go and take let's say 2 days to complete. They go and say it's going to take me 4 days. And that basically go and affect the estimation. Now, further things to go and bear in mind is the organizational culture. You know, you might have an organization culture which thinks it is okay for us to actually not to go and provide good quality estimates and go and actually add the estimates later. Some other environments say, you know what? No, our culture is we need to be very specific. We can't go and lie. We have to go and give correct information. Other non-project related factors. For example, you might have an earthquake that might go and actually influence and doesn't make you able to go and complete your project on time. So there's all of these things that could go and actually affect the quality of your estimates. Now, some things to go and bear in mind when you're trying to create good estimates. What are they? If you want to get a good estimate, go and get someone who knows about that project in hand, who knows about the task you want to do, and get that person to tell you how much that project is going to be taking. Use several people to go and make the actual estimate. Because several people, one person might get it wrong. Many people, it's unlikely they are going to be getting it wrong. Base your estimation based on normal condition, efficient methods, and a normal level of resources. Don't say, oh, I can do this task in 1 day because I'm going to employ 3 people. No, don't do that approach. Just based on normal condition, efficient methods, and normal resources. Use consistent time units in estimating tasks. You know, if you use hours, if you use days, whatever you use, just make that estimation to be consistent. If you have more than one task and task B needs to be completed after you finish task A, don't treat those tasks as they are related. Treat each task by itself. How long do you need for task 1? How long do you need for task 2? Don't make allowances for contingencies. Like, don't say, oh, yeah, the task would usually take me 5 days. But what I'm going to do, I would like to go and actually, you know, add an extra 2 days because I believe it's going to take me more. No, don't do that. Just go and create, you know, don't create contingencies. Don't add extra time. Adding a risk assessment is another thing to bear in mind. You don't want to have anything that surprises you. You basically want to be prepared if something could go wrong so that you are able to go and deal with the risk and estimate that as, you know, risk, and think about that risk while you're trying to go and estimate the time required for a project. So how do we go and make our estimation? There's a different way. The best approach is make a high-level estimate, create what we call a work breakdown structure, which basically lists every single task required to complete the project. Then make a bottom-up estimate where each task in the work breakdown structure estimate each task by itself, how much it's going to go and cost you because you created all the tasks there. And from there, you have a high-level budget, you have a low-level budget. From all the details, you can develop your schedule, you can develop your budget. And if there are any differences between your top-down approach and your bottom-up estimated, you'll be able to go and see what are those differences, reconciling all of those differences, and getting your correct estimation. Now, ladies and gentlemen, there are various methods of estimation. One of them is the consensus method. What is the consensus method? The consensus method is more about, you might have 5 experts. You go and say, this is a project, and you go and say, could you tell me what is the estimate of that project? And they will go, based on their knowledge, they go and tell you what is the estimate. They make a consensus together to go and agree about what the project is going to go and actually cost and how long is it going to actually take. So that's one approach. Ratio method. What is the ratio method? Let's say we are talking about building a house, and let's say the house is 100 square meter. And let's say we go and say that every square meter is going to go and cost me $100 to go and build. That's what the builder want to go and charge me. So if there are 100 square meters, and if there's $100 charged per square meter, then I know that project is going to cost me $10,000. That's what we call the ratio method. So you could use one ratio. I will have 100, let's say, square meter in this home, and it's $100 per square meter, then it's going to be 100 square meter. Let's say in software, let's say you have 4 modules. Every module will cost you $50,000. 4 modules will cost me $200,000. An apportion method is a method that is linked to the ratio method. It's really go and think about percentage. You might say, I want to build a house. Great. You say, all right, you know, construction is going to be 10% of the, let's say 40% of the actual cost. Landscaping is going to be 20% of that cost. Roofing is going to be 10% of that cost. So you basically create percentages relating to how much is the overall cost of your project. Function point method for software. You look at your software, you say how many functions point are they in that software, and based on that function point, you can estimate how long it's going to take you and how much is it going to cost you. You can see here, for example, this is an example of an apportion method. The total project will cost me $500,000. I split that into design, program, testing, document, and produce CD. We know what is the percentage of each of those tasks. 20% of 500,000, that's 100,000. 30% of 500,000, that's 150. And you basically go even further down, 20%. Okay, out of that 20%, you know, I have 10%, 10%, 20%, sorry, 10 and 10, so that's 50,000, 50,000, 30%, 20% of it is here, which is 100,000, 5% is here, and 5% is here, 25,000, 25,000. So you basically work based on the percentages to be able to go and create your estimation. Function point, I have this software. This software has 15 inputs, 5 outputs, 10 inquiries, 30 files, and 20 interfaces. How complex each? Well, the 15 inputs, 2, which is not very complex. The 5 outputs, 6, average complex. The inquiries, 4, the average complex, and so on. So you multiply 15 times 2. 15 times 2, 30. 5 times 6, 5 times 6, 30. 10 times 4, 40. 30 times 12, 360. So you have all of these function points, and based on the function points, you can ask yourself, okay, how long does it take me to go and solve and develop each function point, right? How much time does it take to go and actually complete every function point, right? And you basically make your estimation accordingly. That's all what we call top-down approach to estimation. Bottom-up approach, there's, for example, the template method. What is the template method? I want to build a house. Building a house is similar to building this house. It's similar to building this house. So you have a template, and everybody goes and follow that template to go and create the estimation. Parametric procedures apply to specific tasks. For example, you might not be using the high-level estimation. You might go and say, all right, I want to build a room. Okay, but if I build the room, inside it, there's one room, and inside of that room, I want to go and put wallpaper. So we go down, same as with your high-level estimation, we go down to that detailed task, which is let me finish this room. And in that detailed task, I go and try to create some estimations. Okay, how many meters is the wall? 10, 20 square meter, great. So we're going to basically charge $20 per square meter. The whole room is going to cost you $400. You basically use parametric procedures, which is similar to what we spoke about as the ratio method and the top-down approach to estimation. Range of estimation, you know, we calculate a optimistic calculation, pessimistic calculation, and most likely calculation. And those calculations, we go and actually use them to be able to go and try to get our correct estimation of how much something is going to take or how much is it going to actually go and cost. There's also a combination. You might be using more than one method together to be able to go and create your estimation. This is an example of the PERT method, which is what we're calling here as a PERT methodology. So you have low estimate, you have average estimate, and you have high estimate. pessimistic, optimistic, most likely estimate. Through a formula that uses all of those three calculations, we'll be able to go and get a specific estimate for every particular task. We also consider, while we are making that calculation, every task. Is it low risk, medium risk, high risk? What could go wrong? Because something that is higher risk obviously requires much more higher attention than something that is low risk for us. My friends, anybody have any questions? So there's a question here, what is the weaknesses of the bottom-up approach? The bottom-up approach is going to take you longer time to go and develop, because you're going to have to go and calculate every single task. You're going to have to go and actually estimate every single task. And it might not be something that, let's say, top management will go need. So it is more costly for us to go and develop. But on the other hand, it has a positive, because it is giving you a much more accurate estimation than a high-level estimation. Does that answer your question?
Yes, sir. And is it suitable for the small project or the bigger one?
Look, I would say for big projects, I would basically go and recommend we go and actually make big estimations. Okay,
so like, sir, in real projects, like in any like IT project or something like that, so do they prefer this bottom-up approach?
Yes, in many IT projects, they do actually prefer the bottom-up approach. The reason why they prefer the bottom-up approach, because they can get a much more specific information about how much a specific project is going to go and cost and how long time it takes. It's basically something that they prefer, especially when they are working on the task in details. Saying this is not the actual approach that is potentially preferred for agile project management, because agile project management does very minimum upfront estimations. And that's basically something because it is, they are basically trying to find a more efficient way for them to actually go and operate. So it really does depend on what sort of project we are talking about. But in the agile approach, they prefer a much more shorter sort of amount of calculation in contrast to go and, thinking about the other approach, which is the traditional approach. They want much more estimation to actually go and be completed. Does that make sense?
Yes, sir. And last question, sir. To estimate the cost and time, which approach is best, sir?
Mate, I really can't answer you that, because there's not really one single approach that is the best for everything. There's always more than one approach.
Which one is more suitable in between, like top down or bottom up?
I would say you're going to have to go and use all of them across various scenarios. So you can't say this is going to be, there's no one scenario good for everything.
Okay, sir. Thank you, sir.
No problem. That's easy. So basically, if you are talking, for example, about someone where you have a senior management coming to you and saying, I want to go and investigate whether we are going to go and implement that project within the organization. What do you think? Should we do it or should we not do it? We can't go and say, oh, we're going to go and give you a very detailed estimation, because that would be a waste of time, because they simply want to know whether they should do it or whether they should not do it. So you need to really think about what is the scenario we're talking about here, and every scenario is different, and you get your calculations done accordingly. Does that make sense?
Yes, sir.
Perfect. Any other questions, my friends? Alrighty, so let's continue, guys. Now, there are so many costs available in an organization that we need to go and think about. There are direct costs, there are overhead costs, there are administrative costs. So if you go and think about the direct costs, it's a cost that people go and associate directly with doing a specific task. Like someone who is working as a developer on your project, someone who is going to go and need to go and I don't know, use this, buy this tool for this particular software. Someone who needs this equipment to complete this specific task. So these are things very, very specific. They are clearly chargeable to a specific work package. And this is what we call a direct cost. They're also what we call overhead costs. What are they? In every project, you're going to have someone called the project manager. That project manager needs to go and actually have what? A wage. So he's not doing the task, but it is associated and tied to some project deliverables. His guidance and his experience enable us to go and really get the project to be completed. What about the rent? Well, they need to rent that space to be able to sit in and to be able to get the job done. they need specialized machinery, whatever they need. It's really costs incurred that can be tied to a project deliverable or to a work package. Another cost is general and administrative overhead costs. Organization costs indirectly linked to a specific package that are apportioned to the project. For example, if you go and say, I am using an accountant, and that accountant within the organization spend 20% of her time accounting the money that we spend on that project. So 20% of her wage is going to need to be a general and administrative overhead cost that we need to go and consider to be able to go and calculate our costing accordingly as part of the project. Another thing for you to go and bear in mind. Now guys, this who basically came last week, we've started forming your groups for your assignment. If you see any of your group members not here now, please encourage him, message him, encourage him to come to the class, because obviously there's a lot we are doing and there are some calculations coming up that are very, very important for the midterm exam, for the quiz, and for the final exam. So please make sure they are coming. Please message him as quickly as you can. This brings me to the end of the first chapter, and I want to say thank you very much for your time. But that brings me to the next more complicated chapter that I would like to go and talk about, which is really important. So let me start talking about that very, very shortly. And this chapter is about developing a project schedule. Chapter 6, one of the very important chapters in this textbook, because this is really a foundational chapter for a lot of other things that we need to go and really complete. So what am I going to talk about? We're going to talk about creating a network diagram. This is a very technical aspect of project management. You need to know how to create that network diagram. And you're going to have to go and make a lot of exercises today in the tutorial where you're going to need to go and demonstrate that you do know how to go and create that network diagram and apply it yourself. So make sure you pay a lot of attention today. What are the learning objectives? We're going to understand the linkages between a work breakdown structure and the project network. We're going to go and create a diagram of a project network using an activity on network method. We're going to calculate early, late, and slack activity time. So what is the early time? What is the late time? What is the slack? To name a few. We're going to go and identify and understand the importance of managing the critical paths in an organization, especially one that is, very detailed relation to the project. There might be more than one critical path for us to go and bear in mind at any point of time. It's about really knowing all of these things. We're going to talk about slack. What is slack? We're going to distinguish the difference between free slack, total slack, to be able to go and name a few. Now, ladies and gentlemen, what is a project network diagram? A project network diagram, it's really a flow chart that uses what we call the work breakdown structure information and graphically go and demonstrate and show us, all of these interdependencies, show us how everything basically is really linked out there. So it's basically, we're going to go and show what should happen first, what should happen after, how are all of those activities related, which activity might start first, which activities might start later, all of these things. And the reason why we create a network diagram is because it provides us with the basis of scheduling. We can know when we need the labor. We can know when we need the equipment to be available. We can make it very clear to everybody else what everybody needs to go and be doing. So it really enhances our ability to go and communicate among all of these project participants. It provides an estimate of all the project's duration. It provides a basis for knowing the budget, what budget do we need at any particular point of time, the actual budgeting information that is really appropriate. Identifies activities that are what we know call a critical path. What is a critical path activity? It is an activity that cannot be delayed. It is an activity that if you delay it, it is going to go and delay how long the project is going to take to complete. So it's an activity that should not be delayed. Whatever you do, you try to go and ensure that that activity is going to go and run on time. It highlights activities that are not on a critical path. And if something is not on a critical path, that means that is something that I am able to go and delay. So I need to go and know what can I actually go and delay. especially the ones that basically, if they delayed, I need to know how long can I delay them for. Because sometimes you might not have enough resources. So if you delay one task, you'll be able to go and not delay that task, and you're going to be able to use your resources much more smoothly, as I'm going to show you a bit later. You're going to help the managers to go and stay on the plan. Once you have a plan, it is much more easier for us to be able to go and ensure we are sticking and delivering things according to the plan. So let's talk about this example. This is an example of a project. I have all of these circuit board design. To get the circuit board, I have to design cost account. I have to have a production cost account. I have to have a test cost account. I'm going to have to go and have a software cost account. Okay, great. So what does that mean? Well, I have to do tasks related to design, production, testing, and software. Great. What does that mean? For design, I need to do this activity in this activity. For production, I need to do this activity in this activity. For the testing, I need this activity. And for the software, I need this activity and this activity. Okay. Or I can see I have 1, 2, 3, 4, 5, 6, 7. Great. Let me go and say, when do these activities need to go and occur? Good question. Specifications and documentation, we're going to combine them together. They're going to be the first task. Great. It's going to happen after. We're going to then go and do prototype. Great. What else? We're also going to go and do preliminary software. Great. So prototype, preliminary software, no worries. After I do prototype and preliminary software, what do? I have to go and create the final prototype. Okay, great. So what happens after the final prototype? Well, I'm going to have to go and create the final software. Final software. All right, so you're going to do this. And after you finish the final software, what are you going to do? I'm going to go and test it. Okay, great. So we moved from having simply a list of tasks that I need to complete to something more specific to what do I need to go and complete, but also when do I need to go and complete those tasks. So we're moving to something more specific. I need to really understand when something really needs to go and be completed. So let's go and talk about all of these foundational information. An activity is an element of the project that requires time. It's like write the assignment, build concrete, write the code, test the software, something specific. It is going to actually go and take time for it to go and really go and be completed. And that's something really to go and bear in mind. Merge activity, an activity that has two or more preceding activities. Okay, so there's two activities before it. Okay, great. So D, there's two activities merging into activity D that basically we need to go and bear in mind here. So that's what I call a merge activity. Parallel activities, activities that can occur independently, and if basically we want to and we have the people, we can go and do those at the same time. Okay, give me an example. Well, activity A and B could start at the same time if we have enough resources, but that doesn't mean we can't do A first and then B after. But they could start at the same time because they are parallel activities. Activity C and A could start at the same time because they are parallel activities. What is a pathway? Pathway is a sequence of connected dependent activities. In this example, there's one sequence AD, one sequence BD, and then one sequence BC. So there are three sequences in this example. What about here? We have one sequence CD, and we have another sequence A, B, and D. So there's one sequence, two sequence. That's what we try to go and do. What is a critical path? If there's one pass, two pass, three pass, every activity on that pass will take time. When I count those two activities and count those two activities and count those two activities, you will find out which one is the longest, and that basically becomes your critical path, the path that will take the longest period of time to go and complete. So if this is 5 days, and this is 5 days, and this is 10 days, this is the critical path. Why? Because even if you finish this pass and this pass in 5 days, you will not be able to go and finish the project unless you go and finish activity B and C. So you have to go and really take much more longer for you to go and finish that particular task. So critical path is the longest path throughout the activity network that allows for the completion of all the project-related activities. The shortest expected time that the entire project is going to take to be completed. If one task on a critical path is delayed, the completion time of your project is going to be delayed. That's something to go and bear in mind because these things are really related. Event milestone. A milestone is a point of time when an activity is started or completed. It does not consume time. For example, I might go and have something that says, something along the line that says, module 1 software completed. Did we do any work? Yeah, we did a lot of tasks. But is this module 1 task completed? Is it doing any job? No, it's just simply telling me that I have completed something that is important, and that something that is important is the milestone completion. Testing completed. Yes, we've done so many testing tasks and they consume time, but testing completed is simply talking about something that is done and sorted. It's just basically signifying for me that we will manage to go and get something done. Burst activity, an activity that has one or more, that has more than one activity immediately following it. So you might have activity A, and from activity A, you might have activity B and activity C. So activity B and C happens after A. This is what I call a burst activity, which means from A, I have 2 activities bursting from activity A that I need to go and bear in mind. So look here, A needs to be done first, then we do B, then we do C. Look here, X is a burst activity because there's 2 items or tasks bursting from it. Y and Z have X before it. Y and Z, both of them cannot begin until we go and finish X. Y and Z can start at the same time, but doesn't have to start at the same time if we don't have the resources we need to start those tasks at that time. Look here, M, there are 3 activities merged into it. Every one of those activities could start at the same time. They are in parallel, but they do not all have to go and start at the same time. It's up to you, really. Here, X is a burst activity. There's 2 activities going out from it, and Y is a burst activity. Now, X and Y could start at the same time. They don't have to, but they can. Z cannot start until X and Y are completed. AA cannot start until X and Y are completed. So it's basically trying to create all of these scenarios. Z is preceded by X and Y, which is what I've explained earlier for you guys. Any questions so far?
So here Z and AA can start at the same time?
Z and AA can only start after X and Y have finished. So if X and Y are completed,
yep,
then Z, this is done, which means Z and AA could start at the same time if you have enough resources.
Okay.
Because this AA depends on X and Y and Z depends on X and Y. So they're both basically related.
Okay.
Make sense?
Yep.
Any other questions? I just want to remind you again, guys, to encourage your colleagues to really come. If they haven't already came, so please encourage them to really come and tell them that we're doing the very, very important calculation that they will need for their quiz, their midterm, and their final exam. And I'm about to start that calculation in a few minutes. Look at this example. I have activity A, B, C, D, E, F, G, and H. I have a description for each activity, and I have a preceding activity. What is a preceding activity? What does it mean? Preceding activity is telling me what activity should happen before that activity. So what activity, guys, should happen before A? Look at the example in front of you. What activity should start before A?
Nothing, because it's the first activity.
Okay, so A is the first activity. Great. Okay, what activity should come after A?
That's B.
Okay,
B.
what else?
C and D.
C and D. So
B and C.
B, C, and D could all start after A. Let me ask you a question. Could B, C, and D all start at the same time?
Yes.
Okay, do they have to start at the same time?
No.
No, if we don't have resources, they don't have to. Great. What happens after E?
After E, that's G.
Okay, after E?
You need G as well to get
F.
to H.
Okay, well, let's talk about this. When can I do activity E?
After
B
B and
and
C.
After F.
After, well,
After B and
E
C.
is after B and C. Look, E after B and C. F is after B, C, and D. Let's look at it. A, nothing before it. B, C, and D, they're all after A. So B, arrow from A, C, arrow from A, D, arrow from A. Okay, great. E comes after B and C. So I have E here, arrow from B, arrow from C. All right, I have also F, arrow from B, C, and D. That's F, B, C, and D. So F can start after B, C, and D are finished. What else? G.
So we can count it from the activity time.
What's that?
So we can count it by the activity time, like 5, 15, 10,
Yeah, so
5.
this is the activity time. Okay, don't worry
Okay.
about the activity time. Activity time is only how much it's going to take. So all what you're seeing now to see what comes first, what comes after, is you're looking at the preceding. What activity should come before it? Okay, E, there's B and C before it. So that's E. There's an arrow from B and there's an arrow from C because B and C happens before E. F is there's B, C, and D before it. So F can only start after B, C, and D are completed. G could only start after F is completed. So G is after F, so that's why there's an arrow between F and G. H could only start after E and G. H could only start after E and G. Does that make sense, guys?
Yes, sir.
I'll give you a minute to look at it. Is all clear here?
Yes, sir.
Yes, sir.
All right, so let's go to the more complicated stuff. You see here, we are drawing the boxes in a certain manner. We're leaving this box empty, this box empty, this box empty, this box empty, and this box empty. We're putting in a box here, this one here, which is a duration of the activity, which means A will take 5 days, B will take 15 days, C will take 10 days. And what we're doing also, we're basically having some things here. ES, EF, SL, LS, LF. What does that mean? I have no idea. So now I'm going to teach you about that. Very clearly, it's a very important calculation. Pay attention. We have what is known as a forward pass, so going from here to here, and a backward pass going from here to here. So what is a forward pass? We need to calculate early start, early finish. Early start is the earliest time an activity could start. Early finish is the earliest time an activity could finish. That's what we're talking about here. You know, what are we talking about? We're talking about the early start. How soon can the activity actually start? What about EF? How soon can the activity finish? There's also something called estimated time. What is the estimated time? It's basically this one here. This is the estimated time it's going to take to go and complete the project. There's another thing to go and bear in mind. There's what we call latest start. So you see latest finished, latest start. There's a latest finish, latest start. Latest finish, latest start. Latest finish, latest start. So what is that? Latest finish is how late can the activity start, latest start, and latest finish is how late can the activity finish. And which activities represent the critical path is something we need to bear in mind. These are the activities that cannot be delayed. And how long can an activity be delayed for, which is what we call about slack or float that I'll show you very, very shortly. We have two various types of slack. One of them is called total slack, and one of them is all called free slack. Total slack is the amount of time an activity can be delayed and not delay the actual project. So how long could something be delayed without delaying my project from really being completed? That's the first thing to go and bear in mind. The other thing to go and bear in mind is what we call free slack. Free slack is how long does an activity can exceed its early finish date without affecting the early start of the activity straight after it. So that's obviously a bit different than the other one. The first one is it's without affecting the, without delaying the project. The second one is free slack is without delaying the activity straight after it. What is sensitivity? Sensitivity is the likelihood the original critical path will change once the project is initiated. So sometimes you would find that there isn't a lot of slack really available. Because there isn't a lot of slack available, what this means, it means it could go and actually impact on which activities become a critical path. So if we go and have a path and that pathway have only 1 day of slack, and the other paths have no slack at all, what we need to bear in mind is that one activity of slack, if it was to actually be used, if that activity was to be delayed by 1 day, what is going to happen is we're going to have more than one critical path that is going to go and actually delay the project overall, the project that I'm basically talking about Now, let me go and start teaching you about the calculation. So follow me step by step here. We have, this is what we call the early start, the earliest time an activity could start. When you add the duration of that activity to your early start time, what would you get? You would get what is known as early finish time. And that's what I'm saying here. Early start plus a duration give me the early finish time. So that's basically what we're talking about in that particular example. The early finish time from one activity, which is this activity, becomes the early start time of the activity straight after it. So if you go and look at this second item that I'm showing you here, you go and see, carry the early finish time from the first one, you can see on the left, carry the early finish to the next activity, where it becomes the early start time for the next activity. This basically is what we need to go and bear in mind, with one exception. What is that exception? The exception is if it's a merge activity. So if there's a merge activity, what will happen? So if this is, look, this is a merge activity. So this merge activity has 1 early finish time, 2 early finish time, 3 early finish time. So whenever you have a merge activity, you basically go and use the latest, the largest early finish is basically what you become the early start of the next activity. So if I have 10 here, 12 here, and 14 here, what would I put here? I'll put the largest early finish, so that becomes 14. You're going to say, why the largest? Because we need to find out how long the maximum time the project will take. If you use 10, that is not going to calculate the maximum time. This will give you 14. But if you use this one as 14, it's going to give you 18, which is larger than the 14 that you're going to get by adding 10 to this 4. And remember, we're trying to calculate the largest time this project is going to actually go and take. So let's go and do this in practice. Guys, when can activity A start? Which day?
Day 1.
Well, it's really, this is the early start. It's day 0. We're starting in the first day. Plus 12 days. What would I get?
12.
12. Perfect. What about here? When is the early start of activity B?
0.
All right, so 0 plus
9.
9. What do I get?
9. 9.
Perfect. Okay, now this early start, early finish becomes what?
Early
Early
finish of
start
I.
for I.
Becomes early
Early-
start. Look here. Look here. Carry the early finish to the next activity where it becomes an early start. So this early finish of 12, where does it go now?
I, F, and C.
Okay, it goes to I, F, and C. That is correct. So if we go and put it here, this goes 12. 12 plus 15,
27.
27. Correct. What about here? What do I put here?
12.
12. 12 plus what?
10.
What do I get?
22.
Okay, what about for the third one? What do I get?
12, 10, and 22.
22. So that's basically the start. What about for activity D? What do I put?
9,
9,
10, 19.
19. Okay, and what about for E?
9,
Yeah,
24, 35.
33.
Or 33.
is that clear, guys?
Yeah.
All right, great. So what do I put for G?
22.
22.
57.
Okay, what do I put for H?
19.
Yep.
Plus
59.
59.
Okay, now, what is J? J is a merge activity. There's
33
1,
plus 4.
59.
Do I use
That's
33, 59, or 57?
59.
59 is the largest. 59 plus 4?
63.
63. Okay, I'll give you a second to go and comprehend this part. Is that clear? Why I use 59? Because it's saying you use the largest early finish whenever there's a merge activity. Why the largest? Because we want to calculate the maximum time it's going to take to complete the project. Make sense?
Yeah.
All right. Now, this activity K, is that a merge activity?
Yes.
Yeah.
All right. So it's merge. Which one is the largest?
27.
27.
Are you sure?
Yes.
3.
There's an arrow from here. There's an arrow from here.
33.
And there's an arrow from here.
Oh,
Which one?
yeah. 63.
63 plus 6? 69.
69.
So we calculated the early start, the early finish, and the estimated time in these calculations now. Does that make sense?
Yeah.
All right, now we need to calculate the backward calculations. How do we do it? The early finished becomes the latest finished. So if this earliest finish is 69, the latest finish becomes 69. Okay, so let's look here. Latest finish minus duration, give me the latest start. So what do I put here?
69.
69 minus duration of 6, what do I put?
63.
Okay, I'll put 63. That's correct. Now, the second thing to bear in mind is carry the latest start to the next activity where it becomes the latest finished. So latest start from here becomes latest finish of the one before it. So what's the latest start in activity K?
63.
63.
And what's the latest finish of activity J?
That's 63.
And what's the latest finish of activity I?
27.
The latest finished becomes the latest start. What's the latest finish here?
62.
And what's the latest start here? What should be the latest? Sorry, what What should be the
It
latest
is
finish here?
finished.
What should be here?
63.
63.
That's correct. So we have 63 minus 15. Give me my latest start. So that's here, which is, again, this is 63 here. And again, we have 63 here. So 63 minus 15 give me 48. 63
48.
minus 10 give me
53.
53. And 63 minus 4
That's 59.
give me 59. Perfect. Okay, what I want to ask you now, this latest start here, it becomes latest finish of the one before it. So could you please tell me what would it actually become? The latest start here becomes the latest finish for the one before it. So what should it be here?
59.
What should be here?
59.
59. So 59. Sorry, just bear with me for a second. All right, so let's go back. Okay, so we basically said that this here, J, the latest start is 59. So that from the rule here, we know that the actual latest start, we basically send it to the activity before it where it becomes the latest finish. So 59 will go here and 59 will go here. It becomes 59 and minus 35 is 24 and 59
24.
minus 40 is 19.
It's 19. Yep.
Now let me ask you a question. This 19 here, where would it go?
From D.
It will go to D. Perfect. This 59 here, where would it go?
From E. In E.
It will go to E. This 24 here, where would it go?
C.
For C. Correct. So this 59 came from here. 59 minus 24 give me 35.
35.
And then here we look again here. 19. So 19 here. And this is 24. 24 minus 10 give me 14. And this 19 goes here. 19 minus 10 give me 9.
No.
Now let me ask you here. This one here, the third rule. The next activity is a burst activity. So there's 3 activities coming from it, more than 1 activity coming from it. In this example, you would use the smallest latest finish. So if I go and look here, this is a burst activity. I have 2 latest finish. 1 is 9, sorry, 2 latest start. 1 is 9 and 1 is 35. Which one is the smallest?
9 1.
9.
It
So
goes
9
to
will go
B.
here.
Yep.
Minus 9 equals 0. And what about here? Which one is the smallest here?
14.
14, 53 or 48. 14 is the smallest. 14 minus 12 give me a 2.
2.
So this basically gives me all my calculations here. The final things we need to do is we need to calculate what is known as the slack and the critical path. The longest path, which is the longest duration of the project, it will take 69 days to go and complete, or 69 weeks. So that's basically has been done in this particular example. But if we go and continue here, we need to go and calculate what is called as a slack. What is a slack? Well, the slack, to be able to go and calculate it, we go and have to calculate 2 things. We have to go and use a formula. What formula? The formula is latest start minus early start, or latest finish minus early finish. So let's look here. Latest start is 0. Minus early start, 0.
That's 0.
So what is that going to give me? It's going to give me a latest
0.
start minus early start. It's going to give me 0 minus 0. It's going to give me a 0. 35 minus 9 is going to give me something else. 9 minus 9 is going to give me a
0.
0. 19 minus 19 is going to give me a 0. 59 minus 59, it will give me a 0. And 63 minus 63, it will give me a 0. 2 minus 0, what will it give me?
2.
48 minus 12, what will it give me?
36.
Okay, so you see how we are getting different numbers here. What do these numbers actually mean? It means that any activity which have 0 slack is an activity that cannot be delayed. And any activity that doesn't have a slack of 0, it means it's an activity that can be delayed. How long can it be delayed for? Well, it depends on how much slack do we have. So if you look, for example, here, how many days could I delay activity A, guys?
2 days.
2 days. How long can I delay activity I?
36.
36.
36 days and so on. So it's basically will tell you how long you can actually go and delay any particular activity. Does that make sense?
Yeah.
You're gonna have to go and do a lot of more calculation now. And that's basically only introducing this topic for you, but we're going to do a lot of more application. We used to do that over 2 hours, but now the lectures are only 1 hour. So we basically have to introduce it for you, and then we'll be able to make more calculations and more applications in the actual tutorials. Now, ladies and gentlemen, this is what we call a baseline Gantt chart. What is a baseline Gantt chart? It basically tells you how long do we estimate an activity will take. So look here, we estimate it's going to take 2 days. Look here, this is the actual. So we planned for A to take 2 days, and it actually took 2 days. Look here, we planned for the activity to take 3 days, but it's going to go and take 4 days. That's going to go and delay my project by 1 day. This is really what we call a Gantt chart that you'll learn how to calculate very shortly, and how to view it and interpret it in systems and softwares like Microsoft Project. Now, I just want you to know there are more than one activity. So here I'm showing you what we call as finish to start, because this activity must be finished before the next one could go and actually start. This is what we call a finish to start relationship. There are many other activities to bear in mind. There's, for example, what we call a start to startup in a relationship. That means the next activity cannot start until the first activity start, or finish to finish, which means the next activity cannot finish before the first one finished, or even start to finish, which is the next activity cannot finish before the first one have already really started. We're not going to use a lot of these in the subject, but just so that you would know that there are many relationships that you can go and bear in mind. There are also lags, which mean sometimes an activity could start after a certain lag. For example, I might say activity B, so activity A activity B could only start 2 days after A has actually been completed. This is what we call lag of 2 days. So you don't need to start the activities straight after one finishes. You can have a delayed before the next activity is going to go and start. Look, for example, here, activity Y will start 19 days after activity X finishes. So this finishes, 19 days later, activity Y starts. Look here, trench, this is start to finish. Okay, second activity, which is lay pipe, cannot finish until 3 days. Sorry, lag mile cannot start, this is a start, cannot start until 3 days after trench mile have already started. So you basically have all of these relationships to bear in mind. I'm not gonna, we don't have time for questions now because it's already 4 o'clock, but we can actually go and have much more questions to go and cover and discuss in the tutorial. Please review the lecture slides and the notes you've taken in the tutorial. You need to be very, very much focused on the tutorial activities today. We're going to go and talk about so many very important calculations. If you don't know them, it's equals. You're not going to be able to do quiz calculations. You're not going to be able to do midterm calculations, and you're not going to be able to make final exam calculations. So it's as simple as that. You don't know how to do it, you will lose at least 10 marks in your final exam. So bear in mind that, and make sure you learn every calculation every week. Read chapters 5 and 6 and continue preparing for your weekly quiz, which is next week, and your midterm exam, which is going to be in week 6. Now, ladies and gentlemen, I'm going to say thank you very kindly for your time and effort. We're going to now go and disconnect from this connection, and we're going to go to the next Zoom to be able to go and start our tutorial. So please disconnect from here and go to the next link now. Thank you very much for all your effort. I'll see you very, very shortly.
Thank you.
Thank you very much.
Thank you, sir.
Thank you.